Okay, let's do this one. Applying a function to matrices and data frames. So let's see. Let's review this a little bit. We have a number which we assign to a. We can certainly apply a function to that with square root of a. We get this answer. We can also take a vector and apply a function to that. We've done this many times, and we get the results here. And we can also take a matrix, create a matrix. Now you've learned what this means. Remember, this is we have uniform distribution, and then we take a random, well, I guess we've learned what it is. I didn't explain it that clearly, but we take a random sample from this distribution, and we're going to take 12 numbers, and the number of rows is 3, so the number of columns is 4, because the total number of elements is 12. And so we get perhaps something like this. So this is C. And then we can take the log of C, and it takes the log of every element in there, because remember, a matrix is kind of like basically a vector. So we're taking a function applied to a vector. We get the results usually of each, it's applied to each element of the vector separately. But on the other hand, if we take the mean, that usually only produces a single number, and that's true here also. We get just this number, because basically we're thinking of C as a big vector, and we're just taking the mean of that vector, and we get a single number. He says, notice that the mean of matrix C is a scalar, just a single number. The mean function took the average of all the 12 elements in the matrix. He says, but what if you wanted the 3 row means or the 4 column means? So suppose you wanted to know the mean of this row, the mean of this row, and the mean of this row. Or you might want the mean of this column, the mean of this column, or this column. So can we do that? Yes. We have a function called apply, which will allow us to do that. And you can use any function. We can use the mean or some other function if we want to apply that. And we can apply it to any dimension of a matrix or an array or a data frame. Now, of course, a matrix has 2 dimensions, and so does a data frame, but arrays can have more than 2 dimensions, as we've seen. And this is how you apply the function. I'm sorry, this is how you use apply. So you put in the object that you want to apply to. That would be like a matrix or a data frame name. And then the margin just means you want to do the rows or the columns. And then, if you're talking about a matrix, and then the function you want to use. In this case, we're going to use the mean. And the way that the margin argument, if you put in 1, that means you want to do the rows. If you put in 2, that means you want to do the columns. So let's look at an example. So we're going to this time create a matrix with 30 elements and 6 rows and 5 columns. So 6 rows, 5 columns. Right? Okay? So now we're going to apply the function, apply mean across the rows. Remember, 1 means across the rows. So I want to know that the mean of this row, and then the mean of this row, and the mean of all these rows. So I want 6 different numbers. So I just do this. I use the function apply, name in this case, the matrix, use 1 to indicate that I want the rows, 2 would be, as we said, columns, and the name of the function. And I get a result which has 6 elements, and those are the means of the 6 rows. Now I could use the margin equal to 2, that would mean the columns, and I still apply the mean, and now I get 5 numbers because there are 5 columns. So I get the 5 column means. And since mean has some other arguments associated with it, I guess you can put them here. And like one of them is trim. Remember that trim neglects to include the top 20% of the data and the bottom, no, sorry. Yeah, what is it? Actually, I forget. I think maybe it's the top 10 and the bottom 10%. Okay, I have to check that to make sure. Is it the top 20 and the bottom 20, or the top 10 and the bottom 10? Okay, finally, because the argument here here, the function we're going to use, can be any R function, including a function that you write yourself. We're going to see how to write functions ourselves very shortly in this chapter, how to create our own functions. So this is a useful tool. Now this function, this tool, works for arrays and data frames, but these two kind of variations on it work on lists, and we'll see an example of this one also shortly. Okay, next we're going to go back to his data management problem, which is how to deal with the different kinds of grades he had for his students and how to combine them and so on. We're going to go back and try and tackle that problem.